Hi guys, please welcome. This is an introductory video on mass balance analysis. Before we start with the introduction, please note the following. These videos, they do not substitute your lectures, your tutorials, and your lab briefings. I highly advise you guys to please attend your lectures, your tutorials, and your lab briefings. Thank you so much in advance. Please guys, please attend. I highly advise you guys to attend. Yeah. So the things that you need to keep in mind or know before attempting any mass balance analysis question or any Enviro question is that you must know your chemistry. I know most of you did chemistry in first year, but I highly advise you guys to go back and revise that work. Know the work. Just like you have to know the work, not because you're about to write, but you need to know and understand the work because you don't know which part of chemistry are you going to be tested on. So yeah, so far it's stoichiometry. Stoichiometry is very important. The other thing that's important is your ideal gas laws, all that. And then please also note that you must familiarize yourself with conversions, your units and formulas. Please familiarize yourself with units because if you know your units, you'll be able to convert. And please also familiarize yourself with formulas. I know they're going to give you guys formulas for the exam, formula sheets for the test or exams, but I highly advise you guys to familiarize yourselves with those formulas beforehand because you will know which one to use when. So yeah, please guys, the only way to familiarize yourself with those formulas is if you can do a lot of questions, lots of questions. You can get questions online, you can get questions from your textbooks. Yeah, man, please familiarize yourself with that. So your conversions and your units, I'm not going to go deep into that. I'll just take you through a few things that I noted that were very important with chemistry. With chemistry. And then your conversions, your units and formulas. Please guys, make use of your textbook, the internet, YouTube videos and everything. They are there online. Please do familiarize yourself with that. I'm just gonna take you through the ideal gas law, which I know most of you guys know this law. Yeah. The only trick with this law is you have to know your your units. And the other trick is with the universal constant. When your units for the rest of them changes, like from Kelvin to Celsius, from this to that, from this thing also changes. Please note that. So this is an example from the class. It's a short example on the ideal gas law. It says we want the volume, we have the number of moles, we have temperature, we have the pressure. So yeah, we know what to do. We get the volume using that formula. The other thing that I want you guys to note is your mass, is your concentration. Sometimes they want your molar concentration, sometimes they want your mass concentration. So these two are two different things. So yeah, your mass concentration is measured in your mass per volume, while your molar concentration is measured in your mole per volume. Please note that. Okay, another example on the concentration is this one. They want the molar concentration, or else they give us the mass concentration. And how do we know that they gave us the mass concentration? Because this concentration here is measured in grams per liter. So already we know that when it's measured in grams per liter, then it's a mass concentration. So they gave us atomic weight of each, and then we have to calculate the FW of that. And then, so how do we go on about calculating this? We go on by saying the molar concentration is equal to the mass concentration divided by FW, which is going to be 21 over 142, which is, this is the FW. So, but how did we conclude that this is how we do it? So guys, if you look, your your molar mass is measured in grams per mole, and your mass concentration is in grams per liter. So if molar concentration is equals to grams per liter multiplied by mole per gram, then this and this is going to cancel out, and we're left with mole per liter. See, so you know why I did this, ne? Yeah, I know you know it. So another example is this one. They want us to calculate how many grams of this is needed to prepare a volume of this, of a concentration of the solution, ne? So here we have our atomic weight for each, ne? So we have to find that FW, which is that. It's not necessarily the sum, because we also have to consider like the 4 here multiplied by 16, and then we get that. So the first step that I did here, from here I want the mass concentration. So because the mass concentration is measured in grams per liter, so I wanted to get the mass concentration. So I said the molar concentration multiplied by the FW. So you know that this is going to convert back to grams per liter, or any mass over volume. So this is what I did, and I got that. So immediately when I got that, I knew that if I use this formula here to find the N, I will be left with this mass. But if you don't want to go this route, you can simply cut this process here and not find the mass concentration. Use your molar concentration here to find the number of moles. After finding the number of moles, you're going to jump straight into this one and find the mass. So you can also do that. Okay guys, the other thing that I want you guys to note is this 1 year concentration of a solution in percentage. So this one is when we are dealing with percentages. So if you check here for weight, per weight is W by W, is grams of a substance in 100 gram of a mixture. So here we're dealing with weight of each. And here volume per volume, we are dealing with 100 milliliters of a solution, and weight per volume, we are dealing with 100 milliliters of a solution. So you can see that this is going to be the mass of the solid over the mass of the solution multiplied by 100, because we want the percentage and everything. So if you do not know this, I highly advise you guys to pause the video and copy this and understand this. So I'll do a simple question on this. Okay, this is another example. So here we have a 9 and then they want us to calculate the molar concentration of that in the solution, and then they gave us the atomic weight of each. So yeah guys, the first thing that we can do here, already we know that it's weight to volume, that percentage. So, and we know that our volume, that one is going to be 100 milliliters, and we want our volume in liters. So this is why we divided by, so this one is the amount of the solution. So the amount of the solution is 100 by 10 to the power minus 3, and then we know that this percentage is going to give us this amount of the solute. So we know that it's going to be 0.9, and that is going to be equal to 9 grams per liter. So this is our mass concentration, because here it's 100 milliliters is a volume, and this our weight here, because this is weight to volume ratio. So our weight here is in grams. So this is why we got the mass concentration. And then, but the question wanted us to calculate the molar concentration. So like I told you guys on the previous example, that when you want the molar concentration, is the mass concentration over the FW, and then you substitute your answers and get that. So this is your final answer. So you getting this maybe 2 marks or 1 mark, but remember guys, 1 mark can take you from 49 to 50, and it can take you from 74 to 75 or something. Yeah. So guys, the other example is the dilution solution. So yeah, this equation, you guys know it, but sometimes they trick us with this one. So I'll just show you a few tricks that they tried to trick us with. From this question, they wanted us to calculate the amount of water that should be added to this volume, this initial volume. They wanted us to find the amount of water that should be added to this. So this formula here, it can only give us our final volume, which was the total volume of that solution. But we don't want our total volume of the solution. We want the amount of volume that should be added to this. So that's why we're taking that final minus the initial. So this is the amount of volume that should be added to that solution. And then moving on to this example, this is just an easy example that needs you two guys to read and understand what the question is asking you. So they want you to prepare 1 liter of that, and how many milliliters of concentration of that do we need. So as you can see with the formula, that's what I did, on and on and on and on, and then you get the final answer. This one was a very simple, straightforward example. So yeah, I think that's it. You can also attempt this example and then check and then compare your answers with the one that we got here. Okay guys, the other thing that I almost forgot to mention was when doing a mass balance analysis question, or rather any Enviro question, you must read the question carefully, and your lecturer is going to tell you that make the words talk to you. When she's saying that, she mean it, guys. When she's saying that you must let the words talk to you, she mean it. Because in every word, she's gonna give you like a case study, Nyana, and in that case study there are a lot of things that you should consider. Lots and lots and lots and lots and lots of things. So please guys, read the questions carefully and always think, what does this mean? What does this mean? What does this mean? So that you won't make any mistakes and understand what is being asked. Sometimes they ask us a lot of question in one question, and we always do the final answer. Like we just do the final question and disregarding those other ones that we have been asked. So please guys, please read to understand what's being asked, and always sketch. Your lecturer is going to give you I don't know, it's a process of which she wants you guys to answer her questions. So please follow that, because you can get like 1 or 2 from that, and it comes it's gonna be very helpful. So please guys, please always sketch your work. If you sketch, you get to understand what is going on. All right, thank you guys for watching. I hope the chemistry help you guys to understand, but I highly advise you guys to watch other videos on chemistry, and not necessarily chemistry, but yeah, you can watch other videos, do questions. Guys, please do questions, because if you do the questions, you get to grab the content. But please, before you do the questions, make sure that you understand the content first, and then that's when you can do questions. And if you have any question, please guys, you can drop it on the comments box down, or you can also email it to. Thank you guys.